Alright, so here's an equation. It's a bit longer equation, right? I went right from a simple one to quite a bit more difficult one. It's going to have more steps in it. And so here we're going to go through and follow order of operations, distributive property, combining like terms, and all of our principles of equality. All these things are going to be combined in the same problem, and then our final answer will be in a solution set. So it's really combining a lot of ideas from the last couple sections together. So I'll just run through this fairly quickly using first the order of operations. Well, the order of operations kind of fails because if I go into the parentheses first, there's nothing I can actually calculate or combine because they're all they're all unlike terms. So I got to skip the order of operations and go to the distributive property. Well, the distributive property can be applied 3 different times. Right here, we'll start with this one. First set of parentheses will be 3x minus 12. Okay, distribute, multiply the 3 into both terms. Here I'm going to take the entire negative 4 and distribute that in. So negative 4 times x is minus 4x. Negative 4 times negative 3 is plus 12. Okay, so we're distributing both times on the left. Then on the right, the x and the 3 are unlike terms. They're also out of parentheses, so I don't have to worry about those. I'll bring them down. But the subtraction does have to distribute. Because I'm subtracting an entire set of parentheses, I have to subtract an x and subtract a negative 2. It ends up essentially distributing to both of those, right? So I'm going to subtract an x, and then subtracting a negative 2, well, that's a double negative, which makes it a plus 2, you're adding 2. Some people actually think of these when there's just a subtraction with no like number there. Some people think of it as distributing a negative 1 into the parentheses, and it really is equivalent to that. And so you may hear me say that at times. So negative 1 times x is negative x, negative 1 times negative 2 is positive 2. So they're equivalent to each other. Okay. Then we can combine like terms using the order of operations. And we have all adding and subtracting up here, so that's what we're going to use. 3x, again, we're going to take the sign or the operation that is left of the next term. So 3x minus 4x is negative 1x, or just simply negative x. Negative 12 plus 12, well, that one is 0, right? Those two add up to 0. So those are gone. Then we have the equal sign. Now I have x minus x. Well, this one works out pretty nicely because those two terms are gone. They add up to 0. And then we have 3 plus 2, which is 5. Okay. And so at this point, I have a fairly simple equation. I got to get rid of the negative. I've got to turn it into a 1. So I'm going to divide both sides by negative 1. All right, a negative over a negative is 1, so that, or is positive, and it's 1 in this case. And 5 divided by negative 1 is negative 5. So we have our solution. If I were to check this, I would plug it in to all of the x's in the original equation, and I would show that both sides simplify to the same number. I'm not going to go through that work right now, but that's how you would check this. Once it's checked, and this answer will work out, the solution set is how I want to represent this. And remember, the solution set is simply the final answer written in set form. Okay, that's how I'm going to want you to represent solutions to equations, and that's how my math lab will be having you represent those as well.